This lesson, we will focus on evaluating limits algebraically, which means without using a graph, we should be able to evaluate the limits. So, case 1. In the simplest term, it means if the denominator will not be 0, then we can use direct substitution. So let's look at example 1. When x approaching to 2, if you put 2 in the denominator, it will be 2 plus 4, which is not a 0. That means we can do direct substitution. So we can write this equals 2 plus 3 over 2 plus 4, which is going to be 5 over 6. Example 2. If I put the 5 into the square root inside the denominator, 5 minus 1 is going to be a square root of 4, which is not a 0. That means I can do the direct substitution again. So this equals to square root of 5 squared is 25, 5 minus 1, which is square root of 25 over 4, which means square root of 25 over square root of 4, which is going to be 5 over 2. Example 3, it is a special case. There is no denominator, so supposedly we can put x equals to 3 into the square root to find the limits. However, if you remember square root function, they look very different. So let's try to do a table of values, try to see how does the function look like. So x, y equals square root of x minus 3. Because the value inside the square root can only be 0 or greater than 0. So the first one will be x equals to 3, y is going to be 0. When x equals to 4, y is going to be 1. When x equals to 7, y is going to be 2. So if you look at the function, 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 1, 2, 3. So 3 is 0, 4 is 1, 7 is 2. As you can see from this square root function, there is no left-hand side limit when x approaching to 3. So let's write this down properly. When x approaching to 3 on the right, the limit is approaching to 0. When x approaching to 3 from the left, the limit does not exist. Therefore, limit when x approaching to 3, because the right-hand side and left-hand side, they do not approach the same constant, therefore, it does not exist. Case 2 is when the denominator equals to 0. That means when you have a 0 over 0, or you have an infinity over infinity, we call it indeterminate quotient, then we cannot use the direct substitution anymore. So we have to use a different way to solve for limits. The first method we're going to use is called factoring. So let's try this. For example 4, we know x approaching to 4. So if you put 4 into the denominator, 4 minus 4, you will get 0. If you put 4 into the numerator, 4 squared minus 16 will be 16 minus 16 is also 0. So right now we do have an indeterminate quotient, 0 over 0. That means we cannot do direct substitution. But, however, we can see on the numerator, that's actually called a difference of squares. So we can factor them into x minus 4 times by x plus 4 and divided by x minus 4. And we can divide the x minus 4, whichever they have in common, and then we left with this. And restrictions, x cannot be 4. And then, now, there's no denominator now, so we can do the substitution. So 4 plus 4, so limit is going to be at 8. The next example, example 5. When x approaching to 0, if I put 0 into the denominator, that will be a 0. If I put 0 into the numerator, it will be square root of 1 minus 1, which will be 0 again. So once again, we cannot do direct substitution. However, this time, can we do factoring? No, because there's a square root. So what do we need to do? We have to do rationalization. So whenever you see square root in the function, usually most likely we can do rationalization. And what does it mean by rationalization? We have to multiply its conjugate. If one of the factor is a plus b, then the conjugate will be a minus b. So for example 5, we have limit x approaching to 0. square root of x plus 1 minus 1. So the conjugate will be square root of x plus 1 plus 1. But you have to do for both numerator and denominator. And after that, we just need to expand and simplify. So let's expand the numerator. In the numerator, you have a minus b and times by a plus b, which is difference of squares. So we will have x plus 1 minus 1. And the denominator, please do not expand the denominator, just put them into the brackets. And let's simplify the numerator now. So you have x plus 1 minus 1, you're left with the x. And you copy down the denominator. And as you can see, they have x in common. So fetch out the x, write down restrictions. That'll be a 1 on the numerator now. So x plus 1 plus 1. So now let's check. If I put 0 into the x in the denominator now, where I have square root of 0 plus 1, which means 1 over 1 plus 1, which is 1 over 2. Since the denominator is not 0, so we can do the resubstitution to find the limits. Therefore, the limit is 1 over 2. Let's look at the third type now. Once again, you cannot do the resubstitution because if I put 0 into the x in the denominator is 0, so we cannot do the resubstitution. And I try to use factoring, but factoring doesn't work. I try to use rationalization, but this is not a square root anymore, so I cannot do rationalization. So now we have to learn different techniques. It's called change of variable. Change of variable means you replace the complicated part using one of the variable. So in this case, I'm going to say let u equals to x plus 8 to the exponent 1 over 3. So in this example here, I can replace the x plus 8 to the exponent 1 over 3 into a u, and that will be a minus 2. Since I change the x into u, that means I need to change the x in the denominator into u as well. So let's look at the conditions again. In order for me to get rid of the exponent 1 over 3, I have to cube both sides. That means u cubed equals to x plus 8. And let's isolate for x. So I got u cubed minus 8 equals to x. So I know the denominator x can be replaced by u cubed minus 8. And that's filling the limits. Limit as x approaching to 0. Since I change every single variable x in terms of u, then I have to change this limit as well. So when x is approaching to 0, what does u is approaching to? Let's do some calculation. X is approaching to 0 means u cubed minus 8 is approaching to 0. That means u cubed is approaching to 8. That means u is approaching to 2. There is another way you can do it, is this. Or, we know u is x plus 8 to the exponent 1 over 3. So as x is approaching to 0, then u is going to be approaching to 0 plus 8 to the exponent 1 over 3. So u is approaching to 8 to the power 1 over 3. So u is approaching to 2. Now let's fill this in. So u is approaching to 2. And let's try again. Well, I still cannot put 2 into the u in the denominator because 2 cubed minus 8 will be 8 minus 8, still be 0. Then we have to repeat the process again. I cannot do the resubstitution, so the next thing I tried is I will try factoring. And this time, factoring works now because in the denominator, that's called difference of cubes. So we will write u minus 2 u squared plus 2u plus 4. And as you can see, they have u minus 2 in common. So we factor this out. So u cannot be 2. Make sure you write down the restrictions. And this equals to limits. U is approaching to 2. Numerator is left with a 1. U squared plus 2u plus 4. And now let's try to put u equals to 2 in the denominator. That'll be 2 squared plus 2u plus 4. It's not 0, so we can do the rest substitution now. That will become 2 squared plus 2 times by 2 plus 4. The limit will be 1 over 12. Example 7, if you look at the function now they have two different parts. That is kind of complicated. First part is there is a x to the power 1 over 3. And in the denominator, there's x to the exponent 1 over 2. So whenever you see two complicated parts now, then you want to choose an even smaller exponent. So let's look at 1 over 3 and 1 over 2. The common denominator between them will be 1 over 6. So we will say we're going to let u equals x to the exponent 1 over 6. Then we have to know how to find x to the exponent 1 over 3 and x to the exponent 1 over 2. So we know from x to the power 1 over 6 to the exponent 1 over 3, I have to multiply a 2. This means this. I have u equals x to the power 1 over 6. If I do square on both sides, then I will multiply the exponent. So that will be x to the power 2 over 6. That means u squared equals x to the power 1 over 3. Next one. Once again, let's write this down again. 1 over 6. But I need to get to the exponent 1 over 2. That means I have to times by a 3 to the power 1 over 6. That means I have to do cube on both sides. That means u cubed equals x to the power 3 over 6. So u cubed is going to be x to the power 1 over 2. Now, that's a modified equation. So this equals the limits. And the numerator will become u squared minus 1. And denominator will become u cubed minus 1. And we also need to figure out what u is approaching to when x is approaching to 1. So let's look at this information again. U equals to x to the power 1 over 6. So u equals x to the power 1 over 6 as x approaching to 1. U is going to be approaching to 1 to the power 1 over 6. So u is approaching to 1 as well. So u is approaching to 1. All right, now let's try the process again. So can I put 1 into u into the denominator? No, I cannot, because that's u cubed minus 1, which is 1 cubed minus 1, which is still a 0. So direct substitution still does not work. Then what do we need to do? Now we have to try factoring again. And this time we can factor it because numerator is called difference of squares. That would be u plus 1 times by u minus 1. In the denominator, it's called difference of cubes. So u minus 1, u squared plus u plus 1. And now they do have something in common, u minus 1. So we factor out the u minus 1. Remember to put on restrictions. U cannot be 1. And then we can simplify it to u plus 1 on the numerator, u squared plus u plus 1. And now, can I do direct substitution? Let's put 1 into u into denominator. I get 1 plus 1 plus 1, which is not a 0. That means we are ready to substitute in. And once you substitute in, do not write limits anymore. That means 1 plus 1, 1 plus 1 plus 1. So your limit will be 2 over 3. The next example is another kind that we have to combine different fractions. So once again, if we put 1 into the x into the denominator for the first bracket, you already see a 0 in the denominator, so direct substitution does not work. So we have to do is try to do factoring, but factoring doesn't work because there's nothing to factor here. And then we do rationalization, but there's no square root. Let's replace a variable. There's no complicated exponent. There's no complicated part. However, we do see two fractions in the bracket, in the second bracket. That means we should try to simplify them first. So let's do this. Copy down limit x approaching to 1 and copy down the first bracket. And we're going to try to do a common denominator between the second bracket. So the common denominator will be x plus 3 times by 3x plus 5 minus x times by x plus 3 times by 3x plus 5. Okay, now let's look at the numerator. The first fraction, numerator is 1, but we have to times by 3x plus 5. The second fraction, numerator is 2, but we have to times by x plus 3. And now let's put them into one fraction. X plus 3, 3x plus 5, still in the denominator. Numerator becomes 3x plus 5 minus 2x plus 6. And let's take out the brackets. On the numerator, we get 3x plus 5. Multiply the negative sign in, so negative 2x minus 6. And let's simplify the numerator. You get x minus 1. So as you can see, they have a common factor in both the numerator and denominator, so those two can be divided. Remember to write a restriction down. And we can say that's x approaching to 1. Numerator is 1. Denominator x plus 3. 3x plus 5. Let's check. If I put 1 into the denominator, does that become 0? No. That means we can do direct substitution. And once you put the 1 into the x, you do not write limits anymore. So 1 over 1 plus 3 is 4. And 3 times by 1 plus 5 is 8. So the answer will be 1 over 32. That's your limit. The last case is the very interesting one. That means we cannot do direct substitution because denominator becomes 0. However, none of the techniques that we did before, it work. Factoring doesn't work. Rationalizing doesn't work because there's no square root. Change of variable doesn't work because there's no complicated part or the complex component. And combining a fraction doesn't work because there's only one fractions or one simple fractions. So what can we do? If nothing works, then we have to do one-sided limit. So one-sided limit means before I can find the limits, I have to look at what's the right-hand side limit, what's the left-hand side limit. So let's look at example 9. The right-hand side limit will be 2 approaching to 2 from the right. So you need to think about it. You are on the right-hand side of 2, and it's very close to 2. So you can imagine the x value is 2.00001 minus 2. Then you're going to get 1 over 0.00001. That really means the limit is going to be a very huge number. So we say the limit is positive infinity. And these two steps is what you think. So you don't write it down. Just say positive infinity. And then we do the left-hand side limit. So x approaching to 2 from the left. And you would do 1 over 1.9999 minus 2. Once again, because I substitute a value into the x, so I don't write the limits, then I will do 1 over negative 0.0001. So that means as I getting closer and closer and closer to 2 on the left-hand side, then I'm going to have more zeros in front of the 1. That means I'm going to get negative 0.000001. So if I do 1 divided by a very, very small number, I'm going to get negative infinity. Once again, those two steps are what you have in mind, but you don't really write it down. So this is your thinking components. So I know the right-hand side limit is positive infinity. I know the left-hand side limit is a negative infinity. They do not have the same value and they do not approach to a constant. Therefore, limit x approaching to 2 on this particular function does not exist. The next example is an absolute one. So there are two ways to do it. One is to change to a piecewise function. Second one is we just directly substitute a value on the right and on the left of the 3. So let's try this. Limit x approaching to 3 from the right. Once again, you have to define a value for x. So I'm going to say let x equals to 3.001. then I'm going to have this. This equals to absolute 3.001 minus 3 over 3.001 minus 3, which is going to be absolute 0.001 over 0.001. And absolute means there's no negative sign. So we do absolute of 0.001, still going to be 0.001 divided by 0.001. Your limit from the right is 1. On the left-hand side, you would say approaching to 3 from the left. Once again, you have to define the x value. So I'm going to say let x equals to 2.999, which is on the left-hand side of the 3 and very close to 3. And let's do the calculation. Absolute of 2.999 minus 3, 2.999 minus 3. So this is going to be absolute negative 0.001 over negative 0.001. But because numerator, there's an absolute sign, that means no negative. That means we get rid of the negative sign when you take out the absolute sign and divide it by negative 0.001. So your answer will be negative 1. So on the right-hand side limit, you get positive 1. On the left-hand side limit, you get negative 1 because they do not have the same constant. Therefore, limit x approaching to 3, absolute x minus 3 divided by x minus 3 does not exist. However, do you have a right-hand side limit? Yes, you do. Do you have a left-hand side limit? Yes, you do. But do you have a limit when x equals to 3? No, it does not exist. So let's do a summary. If the denominator it's not 0, then you do the right substitution. That's case 1. Case 2, if the denominator equals 0, then try factoring, rationalizing, change a variable, combine fractions, if none of those 4 work, the final one you can use, that's the last resource. You use one-sided limit. And once again, when you find the limits, once you put the value into the variable, you do not write limits anymore. Here you go. That's the lessons for evaluating limits algebraically.